Hello, my name is Ian Eubanks. I am doing lab 3 for Logic Design. Here's my OWL card, and let's get started. So, for lab 3, I completed the expanding the original equations, X and Y. I did that using a K-map, using these K-maps right here. Simply just put what I did. Well, first off, this right here was, I just saw what value was missing. So as you can see for Y, D was missing. And so I just expanded it that way. And for, it says, so for example, ABC bar, I just saw that ABC bar and then added a D on one and then a D bar on the other. However, I also did it the K-maps way. So what I did was that, so I found the minterms that were 1 and that were also at 0, and then 1 at 0 for Y, and then this is for X. And then I circled the ones, of course, you know, to find the those are just to find the simplified versions of the equation. So all I had to do was just input places, ones, in the places that were missing that seemed as if they were simplified. And this was the fully expanded answer for both functions, X at the top and then Y at the bottom. All right. So here, don't mind this part right here. That was me trying to figure something out. However, this is the truth table. And so as you can see, I have all the minterms on the right, and I have every single combination that could happen with the function. And here I kind of realized to figure out we're using 3 2 to 8 decoders to make a 416 decoder. And so to do that, for one has to be off and then one has to be on. As you can see, all of these zeros go to, you know, 1 2 3 4 5 6 7 all the way to, what's it, 8? I think it's 8. I didn't count it, but I'm sure it's 8, because there'll be 8 outputs, and then it'll be another 8 where 8 is, one of them is on, where the other decoder will be on. And so that's how I decided, you know, okay, so A will just be the one that determines if the other decoder is on and off, which is basically a possibility in itself. So 2 possibilities, and then we can have 3 more possibilities for the other ones. All right. And here is my built diagram of the program, or so say my circuit. All right, so as you can see, D, C, and B are all connected into the 3 input values. And I was having problems to figure out how would we turn on one decoder and while having the other one off, because we have the enabler switches, these 3 right here. These 3 right here, 1 2 3. These are the enablers, and so I had to figure out how, you know, how would we have to turn this one on or have this one on or enable these certain ones. So what I did is when A is 1, it would go to the ground, but this is this makes it min low. This is low, so it reads low inputs. So because this is high, it would turn this off. However, this 5 volt would be on all the time, which would be going into the high input enabler. So because this would always be ground, this would always be high, the A would be determining if this would turn off or on. And so when it was high, this would turn off because this is a low, it takes low values. And then when this is high, however, this would turn on. So that would enable this one to work. So only this decoder would work. However, when it's off, this would be off, causing this enabler to dysfunction and not allowing this decoder to turn on. But when this is off, that would create a low value, which would then in turn allow the decoder to work. And here is my actual circuit. So I'll turn it on. All right. right, and as you can see, all the lights turn on. And so now we will test all of the values. So as you can see, all of these values should work. So we're gonna try B being on and D being on, which will result is X being on, which is this one, this light right here. So B and D are, all right here. So this is, I did a DCB, so I need D and B. So D and B. Oh no, X is this one, my bad. D and B. And so now we can try out, also using the first decoder, the X, we'll try B, C, and D. So B, C, and this light should stay on. All right, hold up. Oh, because, my bad, because A is already on. Sorry, so A should be off. So this is the X. I was wondering why that was happening. So A is off. This value should work, so I'll just start from this. So so B, C, and D are working, all on, and then X should be on. Now we'll try B and D, which are this one and that one. So turn this one on, off. So C, that's C and that's off. And so D and B are on, which makes X on. Okay, so now let's turn it all off. Switch all of these off. All right, and now let's try to make X turn on. So that will be this light using the second decoder. So that will be A on and then D on. So let's use A and then D. And as you can see, the light turned on, A and D turns on. So now we will try to also turn on X using turning on all of the inputs. So that'll be D, C, B, and then A is on. And as you can see, X turns on and also Y turns on. So see both of the lights turning on. So let's turn these off. Now we'll try to turn on the Y values. So this will be D and C will be on, and also A. So D and C. And that turns on the Y, which is the second light. And the Y turns on. All right. And then now we can try A and B. So turn all of these off. So as you can see, A is on. Turn on B. And Y turns on again, the second light. Now we will try, we can try B and D. So that would be this one and this one, and A is also on. As you can see, the Y is on. And now we will try, that's all. Those are all the combinations. So as you can see, my circuit works. All right, thank you. Have a good day.